In order to turn a quadratic equation in expanded form into factored form, you need to factor the equation. One of the most basic types of factoring that can be applied is a method called common factoring. In common factoring, you are looking for factors that each term in the expression has in common. So before we actually try an example, we are just going to practice first identifying common factors. So I've got 3 different sets here, and we're going to take a look at each set and list out all of the factors and then find the factor or multiple factors that they have in common. So let's start with 2 and 4. So what are all of the factors of 2? Meaning, what are all the numbers that can go into 2? So factors of 2 would be 1 and 2. There are no other numbers that go into 2. With 4, we've got 1, 2, and 4. So if we check our lists, the greatest common factor, so that's the other thing too, we're looking for the greatest common factor. The greatest common factor that I see in both sets would be 2. So the common factor would be 2. We're going to do the same thing for 10 and 12. So I've gone ahead and listed out the factors for 10 and 12. So for 10, we have factors of 1, 2, and 5. And for 12, we've got 1, 2, 3, 4, 6, and 12. So again, we're going to look at both of our lists and pick out the greatest number that we see that they have in common. So the biggest number that they have in common, again, would be 2. Okay, what if we were talking about variables? So the same thing applies for each of the variables that we see here. We're just going to list out all of the different things that could go into each variable. So let's start with x. So the only thing that can go into x would be x. However, when you have x squared, the factors of x squared would be x and x squared. So x can go into x squared because we know that x multiplied by x gives us x squared, and obviously x squared can go into itself. So the same pattern would kind of apply for x cubed. You could have x, you could have x squared, and you could have x cubed. So if we check our list, the only thing that shows up, or the only factor that shows up in each set, would be x. So the greatest common factor would be x. Okay, so I created a new set. So I picked 3x and 9x squared. So what if we were looking for the greatest common factor here? So now we have terms that are a combination of numbers and letters. So the same idea applies. We need to list out all of the factors, and then we're just going to look for the greatest common factor amongst our list. So let's start with 3x. So let's start with a 3. What are all the numbers that can go into 3? Well, we could have 1 and we could have 3, and that's it. And then we also have an x. Well, the only factor for x would be x. Our other term is 9x squared. So let's start with 9. What are all the numbers that can go into 9? So we've got 1, 3, and 9. But then we've also got an x squared. So what are all the factors of x squared? Well, x can go into x squared, and x squared can obviously go into itself. So now that we've listed out all of the factors, we need to find the greatest common factor. So we need to pick out the biggest number or the biggest variable that shows up in both sets. So if I scan the numbers first, I see that 3 is the greatest common factor for the numbers. And if I compare the letters or the variables, I can see that x is also a common factor. So we need to put them together and state them together. So our greatest common factor here would actually be a 3x. So not only do they have the 3 in common, but they also have x in common. Now that we know how to identify common factors, let's actually try to factor a quadratic equation. So here's our first example. We've got 0 equals 3x squared minus 6x. Now, one thing you want to take note of, in order to factor a quadratic equation, your equation always has to be set equal to 0. So if for some reason your equation isn't equal to 0, then you're going to have to do some rearranging in order to bring all of the terms over to one side of the equation to get a 0 on the other side. So our equation is equal to 0, so we're good to go. So the first thing I want to do is look at the terms in the equation. We've got 3x squared and we've got 6x. So first thing we need to do is identify what is the common factor between 3x squared and 6x. So I'm just going to go over to the side here and I'm going to list out all of the factors for 3x squared and 6x. So on the side of the screen, I've listed out all of the factors for 3x squared and for 6x. So if I check both of my lists, I want to identify what the greatest common factor would be. So for the numbers, I can see that 3 is the largest number that they have in common. And for the letters or for the variable, I could see that both of them have an x in common. So that means my greatest common factor is going to be 3x. So the way that we're going to utilize that in our answer is we're going to rewrite 0. We're going to rewrite the equal sign. And then I'm going to put in or recopy my greatest common factor that I just identified. So that would be 3x. The next thing we're going to do is we're going to open a big bracket. And what I'm going to do is inside this bracket, I'm going to recopy the question. So that question or the equation was 3x squared minus 6x. And what I'm going to do is from each of these terms, I'm going to divide out our greatest common factor, which was 3x. So my next line is going to say 0 equals, I'm going to recopy the 3x, and inside the bracket, I'm going to perform the division. So we're going to start with 3x squared divided by 3x. So we know that 3 divided by 3 is 1. So we don't have to write the 1 because in math we usually don't write out the 1. And then we've got x squared divided by x. Remember that when you are dividing, okay, we need to follow our exponent law for division, which tells us that we actually need to subtract the exponents. So we've got an x with an exponent of 2, and in the denominator we have an x with an exponent of a 1. Remember, there is a 1 there, even if you don't see it. So if we were to subtract these two exponents, 2 take away 1 would just be 1. So that means we're just going to be left with an x to the exponent of 1. You don't have to write in that exponent. Okay, so x squared divided by x is just x. And then we've got a minus sign. And then we're going to perform our next set of division. So we've got 6 divided by 3, which is 2. And then we have x divided by x. So again, you need to think of your exponent laws. So really this is like x to the 1 divided by x to the 1. Well, 1 take away 1 is 0. So we could write x to the power of 0. However, there is an exponent law that talks about exponents of 0. And if you don't remember it, okay, the rule is that anything to the power of 0 is equal to 1. So we're not going to write x to the power of 0. I'm just going to erase that. Okay, x to the power of 0 is 1. Well, is there a point of putting in the 1? Well, not really, because what is 2 times 1? It's just 2. So you don't actually even need to write out the 1. So our answer is just simply going to be 2. And the portion now that is left over, 3x multiplied by x minus 2, this is your factored expression. So we started with an expression in expanded form, and we finished with an expression in factored form. So now how do you know that you did this right? Is there a way that you can check your answer? And the answer to that is yes. You can simply take the answer that you just created and you can distribute it. If you distribute, you should be able to generate or regenerate your original equation. So let's go ahead and do that on the bottom of the page here. I just want to show you that our answer is correct. So if I take our factored equation and I distribute, let's see what we would get. So 3x multiplied by x is 3x squared, and 3x times a negative 2 is negative 6x. And if we check, yes, this is the exact same as the original equation that we started with, so therefore we know our answer is correct and we did the factoring correctly. All right, now it's your turn to give it a try. You have a brand new equation. You are going to factor it using the common factoring method. So pause the video, give it a try, and then you can come back to check your answer. So the first thing that we need to figure out is what is a common factor between 25a squared and 20a. So on the side of my screen here, I've gone ahead and listed out all of the factors for each of the terms. Once I've done that, then I just need to scan and check what the common factor would be. So in terms of the numbers listed, the greatest common number that I see between both lists is 5. And in terms of the letters, they have an A in common. So our greatest common factor between both of these terms is going to be a 5A. So I'm going to go back to my equation. I'm going to recopy the 0. I'm going to recopy the equal sign, and I'm going to insert my greatest common factor that I just identified. So that would be the 5A. So I've put that in. And then our next step is to make a big bracket. I'm going to recopy the question. So I've got 25a squared minus 20a. And then to each of those terms, I'm going to divide them out by my common factor, 5a. So I'm going to go ahead and recopy 0 equals 5a. And then inside the bracket, I'm going to go ahead and perform that division. So we start with 25 divided by 5, which is 5. And then we've got a squared divided by a, which is a. We have a minus sign. Then we've got 20 divided by 5, which is 4. And then we have a divided by a. Okay, that's just going to simply cancel out, as we discussed in our previous example. So I'm just going to cross that out. So our final answer is 5a multiplied by 5a minus 4. And again, if you want to check your answer to make sure that you factored it correctly, you could simply just distribute. So if we do that really quick, 5a times 5a is 25a squared, and 5a times negative 4 is negative 20a. So we get the exact same equation that we started with in the original question, so we know that we did it correctly. All right, what if we had something that looked like this? So we've got 2b is equal to negative 3b squared plus 17b. So remember, in order to factor an equation, it needs to be equal to 0. But this equation is not set equal to 0. We've got terms showing up on both sides of the equation. So what we want to do is just gather or collect all of the terms on one side. Doesn't matter that they're like or not, but everything just needs to be on the same side. So it's up to you how you want to do this. You could either take this 2b and bring it over to the right-hand side, or you might choose to move all of the terms over to the left-hand side. So most students would take this 2b and move it over to the right-hand side. I'm just going to be a little bit different and just show you that it doesn't really matter. I'm going to take both of these terms and bring them over to the left-hand side. We're going to get the exact same answer at the end. The factoring might look a little bit different, but the answer should still work out to be the same. Okay, so if I bring negative 3b squared over to the left, that's going to give me a positive 3b squared. And then I'm going to have negative 17b, and then we still have that positive 2b. So there would now be a 0 on the right-hand side because I've brought everything that was originally on the right-hand side over to the left-hand side. So again, before we start factoring, are there any like terms that we can put together? Well, I do see that there are two terms that have b's. These can be put together. So I can take negative 17b and add 2b. So that's going to give us, we still have 3b squared. Negative 17b plus 2b would be negative 15b. All right, so now we've simplified it as much as possible and we are ready to factor. So we need to first identify what the greatest common factor is going to be between 3b squared and 15b. Now, the better that you get at it, the more practice that you do, you won't have to keep listing out all of the factors on the side of your page. You're probably going to get really good at doing it really quickly, and you should be able to kind of pick it out in your mind. So let's start with our numbers. So between 3 and 15, the greatest common factor would be a 3. And between b squared and b, our common factor is going to be a b. So our greatest common factor is 3b. We then make a big bracket, still equal to 0. Inside the bracket, I'm going to recopy the expression, 3b squared minus 15b, and each of those terms is going to get divided out by my common factor of 3b. And now we're ready to perform that division. So inside the bracket, we've got 3 divided by 3, which is 1, and we've got b squared divided by b, which is b. We have a subtraction sign. And then we've got 15 divided by 3, which is 5. And then these b's, b divided by b, they're just going to cancel out. So our final factored equation would be 3b multiplied by b minus 5. All right, let's take a look at a different kind of common factoring example. So we've got an equation that looks a little bit more complex. So we've got 5x times x minus 2 minus 3 times x minus 2 equals 0. So remember, the first thing that we always try to do is identify a greatest common factor. But when you're looking at this, there's just a lot of stuff happening here. So while it may not be quite as simple to list out all of the factors and then pick or identify from that list what the common factor is, let's just scan each of these as two different sets. So I'm going to color one set in this red color, and I'm going to color this second set in this blue color. So if I look at the first set compared to the second set, is there something that shows up in both of these sets? So what I do notice is that both of them have x minus 2 in common. It shows up in both of these sets of terms. So because of that, I can say that my greatest common factor is actually x minus 2. So your greatest common factor doesn't just have to be a number, it doesn't just have to be a letter, it doesn't just have to be a number and a letter, it can actually be a binomial like x minus 2. So now that I know that x minus 2 is my common factor, the same method of factoring still applies. So we're going to go ahead and write out our common factor at the front. We're going to open a big bracket, still equal to 0. We're going to recopy the original statement. And remember that everything gets divided out by your common factor. So, looks super complicated, but it's actually a lot easier than it looks. So I'm going to recopy the common factor. I've got my bracket, still equal to 0. And inside the bracket, we're going to perform the division. So let's start by looking at the first set. So what I notice in my first set is that I've got an x minus 2 in the numerator and an x minus 2 in the denominator. So because I see x minus 2 in the top and the bottom, A simple assumption that we can make is that they cancel out. So if they cancel out, the only thing that's left over is 5x. And so we're going to put that inside our bracket. We've got a minus sign, and then we're going to look at the second set. So we've got x minus 2 on the top. We've got x minus 2 on the bottom. So again, because we see it appearing in both the top and the bottom, we can simply just cancel it out. So the only thing that would be left is the 3. And we're going to put that inside our bracket. And that's it. This is our final factored equation, x minus 2 multiplied by 5x minus 3. So here's one for you to try. Same idea as the example that we just did. We've got 3x minus 2 squared minus 4 times 3x minus 2 equals 0. So before you begin looking for common factors and whatnot, let's just remember, what does it mean when we see something in a set of brackets raised to the power of 2? Well, that tells us that we need to write it out twice. So I'm going to do that first. All right, so now we are ready to look for a greatest common factor. So if you'd like to try it yourself, pause the video and then you can come back and check the final answer. In order to solve this equation, the first thing that we need to do is identify what is the greatest common factor. So by looking at it, what appears in the first set? So here's our first set, and what appears in the second set? So what I see that they have in common is a 3x minus 2. So that means my greatest common factor is going to be 3x minus 2. So I'm going to start by placing that common factor of 3x minus 2 at the front of my equation. I'm going to open up a nice big bracket. We're still equal to 0. And we're going to recopy the original question. And each term, or each set of terms, is going to get divided out by our greatest common factor of 3x minus 2. Okay, so we recopy. And now we're going to divide. So if we look at the first set of division, remember our rule or assumption that we can make. If we see 3x minus 2 on the top and the bottom, we can simply just cancel them out. So I'm going to cancel out a 3x minus 2 from the top and a 3x minus 2 from the bottom. So all that would be left is a 3x minus 2. So I'm going to recopy that in here. We have a minus sign, and then we move on to the second set. So again, I see a 3x minus 2 in the top, or the numerator, another 3x minus 2 on the bottom, or the denominator. So I'm going to simply cancel them out, and all that would be left is a 4. So I'm going to recopy that inside my bracket. So this would be my final answer. 3x minus 2 multiplied by 3x minus 2 minus 4 equals 0. The last example are what we like to call challenge problems, and at first glance they may seem very overwhelming because there are lots of variables and exponents, but I think it's good practice to give it a try. You're still going to use common factoring in order to factor each of the 3 quadratic expressions, and give them a try. When you hit pause and come back to the video, you will see the correct answers on the screen in front of you. And if you'd like more detailed explanations or clarifications, make sure to ask during our class tutorial time.